In this LearnElectrics video, the 6th in our video shorts series, we will look at the changes that affect RCD testing and in particular at Type AC and Type A devices. There are significant changes to this part of the testing process, and fortunately for us, they do actually simplify the process. The big change is that Table 3A in the old Blue Book, the RCD performance data, has been deleted. Regulation 643.8 on page 237 tells us that where RCDs are required for additional protection, then we should confirm that the relevant requirements of Chapter 41 are met. In this case, requirements means that they must comply. The device must meet the numbers, no ifs, no buts. And Chapter 41, Regulation 415.1.1 on page 79 tells us that a 30 mA RCD is required. Let's look at the changes to the tripping time requirements. What then has replaced Table 3A? Look at Regulation 643.8 on page 237, and the note there states that regardless of RCD type, effectiveness is deemed to have been verified where an RCD disconnects within the time stated with an alternating current test at the rated residual operating current of I delta N, in other words, 1 times the tripping current of the device. For a general purpose, non-delay type RCD, this is a maximum tripping time of 300 milliseconds for all RCD types. The 5 times test is no longer a requirement of the wiring regulations, but the product standard indicates that this should be a maximum of 40 milliseconds when tested at 5 times the rated tripping current. For S-type delayed RCDs, the product standard gives a minimum and maximum tripping time. The device should not open in less than 130 milliseconds, and it should be open within 500 milliseconds. This is to give some discretion and to allow other non-delay types to operate first. If we can understand types AC and A RCDs, then we can easily transfer this knowledge to other types. Looking at the type AC first, this was, for many years, the most common type of RCD. The sine wave symbol on the front indicates that they are only for use on AC circuits that have no DC elements in the waveform, which for many years was in fact the case. But technology moves on, and now we have many smart devices and lots of appliances with inbuilt electronics that are connected to the circuit. These DC elements and pulses can make the older type AC RCDs less effective. And these are now being superseded with Type A RCDs. The symbol on the front shows an alternating current sine wave and a pulsed DC waveform. The Type A RCD should now be the first choice device. So how should we now test these RCDs? Just what are the changes to the testing procedure? This table shows the AC type device and the test figures that we are all familiar with. A 30 mA device tested at 30 mA should trip in less than 300 milliseconds and within 40 milliseconds for a times 5 test at 150 mA. But look at the Type A device. A times 1 test for a 30 mA Type A should be carried out with a meter output of 42 milliamps. This is 1.4 times 30 milliamps. And should we wish to test at 5 times, the test current should be 350 milliamps. Many wholesalers have expressed concern that electricians are not aware of this increased current requirement, and they are experiencing a bigger than normal return of so-called defective RCDs, when in fact the device is perfectly okay. It is the testing method that is at fault. Some of the newer, more advanced multifunction testers have a setting for each of the RCD types and will automatically cater for the change when set up correctly. Test meters should be to BS EN 61557-6, but what do you do if your meter does not have this facility to test different types of device? What we can do is a little mathematical trickery and set our meters to overcome this problem. How do we output 42 milliamps as a test current? The solution is to set your meter to 100 milliamps at times a half to get 50 milliamps, and 50 milliamps is acceptable as a test current for a 30 milliamp Type A RCD 1x test. There are some much older test meters that do not have a times half setting for 100 milliamps, so you may consider using a ramp test instead. This will give an indication of what current the device actually tripped at, but may not indicate the actual tripping time. There sometimes comes a point when a nice shiny new meter is needed. For a times 5 test, a 350 milliamp test current is required. This is not a mandatory test, but sometimes useful for fault finding. If you have a more modern meter, it may have a VAR or variable setting. You can set your meter to 70 milliamps at times 5, and 70 times 5 is 350 milliamps. And just briefly on other RCD types, as shown here, we can imagine RCDs following a sequence of capability. If we start with a Type AC RCD, we will find that a Type A is similar to a Type AC, but with some extra functions built in. For a Type F, this is a Type A with extra capability, whilst the Type B is the same as a Type F with even more functionality. And we will look at these in more detail in a later video, how they work, where to use them, etc. And there we are. We hope you found this short video useful and beneficial. Thank you for watching this video. It is very much appreciated. Please subscribe to our channel to get access to all of our videos, and remember to click on notify to be sure of not missing our next video. And you will find even more information, videos and help on our website at LearnElectrics.com. And don't forget that you can also type in LearnElectrics, all one word, into the YouTube search bar to go directly to our channel at any time from any computer. We are constantly adding new videos to our channel. Don't miss the next one. And once again, thank you for watching, and we hope to see you again very soon.